Alrighty, guys, we are moving on. Grab your notes. We are moving on to dividing rational numbers. Now, this is something that makes perfect sense, again, if you draw it out. And it doesn't have a lot of use as itself, but it has a lot of use in later math. Okay? And it actually has a lot of use in cooking, believe it or not. But we'll come to that in a moment. First thing we got to do, though, is understand something about dividing rational numbers. Dividing rational numbers is simply the inverse operation to multiplying. And you guys know that already. Division and multiplication are related, just like addition and subtraction are. If 5 times 2 is 10, 10 divided by 2 is 5. When you change the direction, you use the same numbers, and it works. Same with adding and subtracting. 3 plus 4 is 7. Change the direction, 7 minus 4 is 3. Right? So that piece of knowledge means you have to be aware that just like subtraction doesn't really exist, it's just adding the opposite, division is very similar to that. Division is just multiplying by fractions, which is what we're going to do right now. The first thing we're going to do is remind ourselves of this. Since it's related to multiplying, the rules stay the same. Negative, negative, they're the same sign, so what's my answer going to be? Positive, positive, they're the same sign, so it's going to be positive. And then when they're different signs, it's going to be negative. That rule doesn't change. Okay? Everybody cool? Yeah. All right. In English, not in English class, in the English language, if I divide something, what am I doing to it?
Cutting in half.
Does it have to be in half, Panit?
No.
No, I'm cutting it into smaller bits, yeah?
Yeah.
Okay, so I'm going to draw a bar here. How many did I draw? 1. So that is 1. If I start dividing that, I'm going to be chopping it into littler pieces, yes?
Yeah.
Now, for our argument's sake, to teach you guys this, I am going to divide it into pieces that are the same size, right? That's how fractions work. I mean, if I put a line here, have I divided it?
Yes.
Yeah, but it's not pretty, so we're not going to use that. So I'm going to go ahead, that's 1, yeah? Okay, so if I want to divide that into 4, I'm going to cut it into 4 pretty close to equal chunks. Is that cool? All right. What I have just done in English is taken 1 and divided it by 4, yes?
Yeah.
What would that look like in math class? How would I write down what I just did in math? 1 divided by 4, yeah? Now, how do we write that in real math classes? Not grade 3 when we learn division. What would we write? What have we been writing all this semester so far? Fractions. This is 1 over 4, correct? Now, that 1/4 is this bit right here. Is everybody cool with that?
Yes.
Yeah? Okay. Now, what we're going to do is we're going to take what you just saw, which you already know, and we're going to apply it to fractions. Okay? We're going to take everything we already know, and we're going to apply it to fractions. Cool?
Cool.
Okay. So here we go. 4 divided by 2. What's the answer? 2. Easy peasy lemon squeezy, right?
Yeah.
Okay. 4 times 1/2. What's the answer? 2. Why?
Because 1/2 is half of 1.
Exactly. There's a half, yes?
Yes.
And I need how many of them according to this question? 4 times a half. Now there's 1, there's 2, correct? Yep. That makes 1 whole and a second whole, which is 2. Everybody good? Okay. Now, how should this 4 really be written? 4 over 1. And then you guys are smart kids. Multiply straight across. 4 times 1, 1 times 2, 4 over 2, 4 over 2 is 2. Cool?
Cool.
All right. Now look at this. How should this 4 really be written? 4 over 1. How should this 2 really be written? 2 over 1. What do you notice? I have a 2 and I have a 1. I have a 2 and I have a 1. But they've flipped over, yes?
Yes.
But I get the same answer. Does everyone see that? Now you guys all need to follow the most important piece of logic you are ever going to learn. This is the only logic that you need in real life. Everybody else that talks about taking logic courses and things, it's like going to the gym to make your muscles pretty. What I'm about to show you is the single most important piece of logic you will need. It will get you through all of math. It is this. A equals B. Anything equals this other thing. Is everybody cool with that? B equals C. So B equals this other thing. What does that mean for A and C?
Is the equation C the answer?
Nope. A is B. They're the same. B is C. What does that tell you about A and C? A is also C. Does everyone understand that piece of logic? So now come back and apply it over here. If 4 divided by 2 equals 2. Everybody cool with that? There's A, there's B. A equals B, yes? And 4 times 1/2 equals 2. There is B again, isn't it? But this is not A, this is something different. What is this now? There's B again and there's C, yes? B equals C. Everybody cool? So what does that tell us about A and C? That they're the same. So that tells us that 4 divided by 2 is the same as 4 times 1/2. Right? Now, what is the beautiful thing about math? If it happens once, what do you know? It'll happen every single time. So if you take any number and divide it by any other number, it is the same as multiplying by that number flipped over. Is everybody cool? Always. No matter what. Everybody with me? So all I have to do is change this division sign to multiply and take the second number, whatever it is, and flip it over. And then we're back to multiplying, which we just did for a whole period. Right? So, here we go. Do I have a number? Yes. Divided by this number, yes? Now, I already know that division is the same as that same number multiplied by what? What did we do right here?
Multiply by the fraction.
Multiplied by the fraction. We flipped it over, yeah? We took 2 over 1 and made it 1/2. So what are we going to do with 9 over 8?
8 over 9.
Make it 8 over 9. Why did I get rid of the negative sign?
Don't care about it.
Why don't I care about it, Aiden?
Because you can put it in the answer at the end.
I can put it in the answer at the end. I know this is going to be negative. So why would I keep it in there and mess with my head? Right? I know my final answer is going to be negative something. So I've thrown it out. It's out of my head. Don't let it bother you. So now I've got 3/4 times 8/9. Hey, wait a minute. Multiply. I know how to do that. Where do we check first? Diagonally. Do 3 and 9 work together?
Yes.
With what?
3.
3. How many 3's fit into 3?
1.
1. How many 3's fit into 9?
3.
3. Do 8 and 4 work together?
Yes.
How many, what number?
2.
Higher.
4.
4. How many 4's fit into 4?
1.
1. How many 4's fit into 8?
2.
2. What's 1 times 2?
2.
2. What's 1 times 3?
3.
3. And my negative's already waiting for me.
So it's kind of like the adding and subtracting. You're dividing and multiplying.
Yep. And that is always true. Now, I said to you it's going to come into play later on, and it will. For example, in the 10th grade, you're going to see something that looks like this. 4 pi r cubed divided by 3. And then you're going to have to divide that by 2. That looks awful, doesn't it? But you guys now know that isn't divided by 2 the same as times a half? So wouldn't this be 4 pi r cubed over 3 times 1 over 2? And then 4 pi r3 times 1 is just 4 pi r3, and 3 over 2 is 6. And this horrible, ugly thing becomes 4 pi r cubed over 6. And that's a lot easier to deal with than a fraction divided by a fraction. Everyone understand? Here's the next time it'll come into play. You don't need to write this down. This is for later. But later on in your math career, you're going to get things like this. 3 3/4 divided by 3 4/7. A fraction divided by a fraction, barf. But you guys are smart enough to know that that is 15 over 4 divided by 25 over 7, yes? And you guys are also smart enough to know that divided by is the same as multiplying again, isn't it? So doesn't this just become 15 over 4 times 7 over 25? That's why it's useful. Okay? Now let's come back over to here and let's make sure we know what we're doing. But there's a couple of things I would like to remind you of. First thing I need to remind you of is check your neg and positive signs. So you know what your answer is going to be. Don't waste brain space. Oh, at the end, was there a negative? I can't remember. Oh, multiply by a negative, is it positive? Forget about it. Check first. And number 2, remember, we must change to multiply and we reciprocate the second number. Now, what does reciprocate mean in English? Flip. Everybody with me? And it's only the second number that we flip it. Now, do all the other multiplying rules apply?
Yes.
Yeah. So, what if it's a mixed numeral?
Same thing.
Same thing as when we multiply. We got to turn it improper, but we'll get to that in a minute. Everybody good? Let's check. As always, here is a long version. We'll fill it all in. Over here, you try it on your own. First thing I check, positive, negative. So what's my answer going to be? Negative. So boom. Now we just work with it. Divided by becomes times. First step was done for us. What do I do to the second number? Flip it to 4 over 3. Right? Agreed? Okay, now check. Do 2 and 3 work? Nope. Do 4 and 5 work? Nope. So we got to leave it the same. What's 2 times 4? 8. What's 5 times 3? 15. And we're cool, yes? Anybody got any issues? Okay. Let's look at the next one. Step 1, check. Negative, negative. So what's my answer going to be? Positive. So forget about the negative signs, right? Step 1, do I change the first fraction? Nope. 2/9. What do I do to divide it by? Make it times. What do I do to the second one? Flip it. 7/4. Do 9 and 7 work together? Check diagonally. No. Do 2 and 4?
Yes.
Yes. What number? 2. How many 2's fit into 2? 1. How many 2's fit into 4? 2. Now check up and down. Do 7 and 2 work? No. 1 and 9?
Wait, no.
No. So I just go straight across. What's 1 times 7? 7. What's 9 times 2? 18. And I'm done. Is everybody cool? Okay? Now, we did 1 with all the steps. We did 2 with me talking about it. You're going to do a third one completely on your own. You guys are going to write it down. You ready? No. Because you just had a 10-minute break. Lick them. Go sit down. Here's some paper towel. Would anybody like to walk us through this? Aiden?
So, what's 3 over 7
3/7, because I don't change the first thing.
times
Times
21/12?
21 over 12, which, by the way, I chose because it's the name of Rush's best album, Rush being the greatest band ever.
And then 7 can go into 21.
7 and 21 work together.
Yes, so you can cross off 7 and put a 1. So you can cross off 21 and put a 3. And then 4 and 12 and 3 go together. You can cross off 3 and put a 1. And you can cross off 12 and put a 4. And you do 1 times 3 is 3. And put 4.
Done. Is it positive? Of course it is, because they're the same sign. Is everybody cool with fraction division? All right. Turn the page over. Now we're going to talk about dividing rational numbers. On your calculator, we all know how to do this, yes?
Yes.
How would I punch this into my calculator? What button would I have to hit?
You have to put the same thing in, but instead of divide, you put times.
Now, on your calculator, there's a dividing button. So you can go, I like to do my calculators in green, the negative button, 5.1 divided by 3 and equals. And what do you get?
1.7.
Negative 1.7. Cool? Everyone is good, yeah? All right. Now, does anybody remember how to divide without a calculator? Aiden does. Anybody else? You kind of do, Dylan? Okay. Well, division is related to multiplying, right? And when we multiplied decimals, we forgot about the decimal till the end, right? So do you think we do the same thing here? Kind of. We got to do this. 5.1, we're going to divide it by 3. So we don't want to worry about this decimal, yeah? So we're going to get rid of it. I'm going to move it over. We're going to leave it right there for now. How many 3's go into 5? 1. 3. 5 minus 3 is 2. Bring down the 1. How many 3's go into 21? 7. 21. No remainder. How many decimals were in the answer? 1. How many decimals need to be, how many decimals were in the question?
1.
How many decimals need to be in the answer?
1.
So it's 1.7. Everyone remember that? There's lots of shortcuts to dividing decimals. I'm only going to show you 1 or 2 because let's be honest, we'll be using our calculators 99 times out of 100, right? So let's have a look at this. This is the second shortcut I'm going to give you. Divide integers. What's an integer again? Who remembers what an integer is? Dylan? Whole number, no decimals. So this becomes 75 divided by 5, because I don't want any decimals, yeah? So 75 divided by 5, and I know that's 15. You guys are smart kids. 1 decimal place. So how many decimal places do I need? 1. 7.5 divided by 5 is pretty darn close to what? Which of those? This is an estimating situation, yeah? How would you estimate this? What's 7.5 close to? 8. And what's 5 close to that works well with 8? 4. What's 8 divided by 4? 2. So I need this to be a decimal that's close to 2. What is it? 1.5. What's missing from that? It's negative because one of them was negative. Does everybody see this estimating, how it helps them out? Again, it's not that useful except to check on a long question when you got a lot of calculating to do. It's a good idea to take that estimate for a sec. Okay? Now, you will notice that you have a bunch of white blank space at the bottom, yeah? That's there for practice right now because we haven't done any mixed numerals, have we? But you guys are smart kids. Let's go 2 1/5 divided by 3 2/10. Now this requires you to know every single thing we've done with fractions up till now. What's the first thing you need to do? Why? Can't deal with the big numbers when we're dividing and multiplying. We have to do improper fraction. Hey, Panit, take your desk and go sit in the hall because you don't give a rat's ass. And when Mr. Newton walks by, you can explain why. Nothing. Exactly. Go sit in the hall. You don't care. You can listen to me out there. You haven't written anything down in ages. You obviously don't need to see the screen, so just go out there and listen. There's desks right by the door for you. And when I walk over to that door, I better see you still sitting there. I know, okay. Why do I got to go to improper fractions?
Because you can't do it with the big number.
Can't deal with the big numbers. So what is the first one? 11 over 5. You can go ahead and start on the next section, Paneek, because obviously you don't need notes. So you can go ahead and start on page 134. What's this one going to be?
32.
32 over 10. Can't do division, so what's my next step?
Times it.
To what?
11 over 5 times 32 over 10.
10 over 32. Now what?
See if you can.
Is there anywhere I can change it? Where?
5 and 10.
Great. What number works with 5 and 10?
2 and 3.
Kind of. It's 5, right? How many 5s fit into 5?
1.
How many 5s fit into 10?
2.
There's your 2, right? Now, no more diagonals work? So what do I check then?
Vertical.
Up and down. Do 2 and 32 work?
Yes.
What number? 2. How many 2's go into 2? 1. How many 2's go into 32? 16. Right! Now, nothing else will change. 11 times 1 is 11. 1 times 16 is 16. Everybody cool?
Yeah.
I'm going to write one more up, or you're going to do that while I go talk to our good friend. 3 2/3 divided by 1 2/6. Oh, and let's make that one negative.
First thing, get another bag. Yes, we go to the proper first. What? Okay, then. Close. When you put this, what's the
Everybody Gouda?
Well,
Nice. So, we're going to skip some steps here. We're going to do some in our head, right? What's this going to be?
11 over 3.
11 over 3. What's this going to be?
6 over 8.
8 over 6. But we're going to change it to... It was 8 over 6. We're going to change it to 6 over 8. Yeah? Now we're going to check our diagonals. Does anything work?
Yes, 3 and 6.
3 and 6. What goes into 3? 3 goes into 3 once, goes into 6 twice, yeah? Diagonals are done. Do any up and downs work now? Where?
2 and 8.
2 goes into 2 once, goes into 8, 4. 11 times 1, 11. 1 times 4, 4.
Negative on the 11.
And, excellent, didn't fool anybody, you need a negative. Cool? Now, of course, I would like to show you the one time in your real life that you will actually divide fractions in real life, and it's cooking. Okay? If I got a recipe that calls for 7 2/3 of a cup of something, and that's how much I need to make enough food for 25 people, but I only have 5 people in my family, What do I got to do to this?
Improper fraction.
7 2/3 of a cup will make it for 25. I only need it for 5. So this has been divided by 5, so what do I got to do here? Divide by 5. And that's when dividing by fractions comes in.
Would you change it to different?
Of course you would. Yep, you would do 23 over 3 times 1 over 5. And that would tell you how many cups you would need to do that for your family instead of. The way I use it in my real life is I grew up working in restaurants. That's how I paid to go to university. I would steal recipes from the restaurants that were good for 150 people because I like the restaurant food. Doesn't do me any good because I don't have 150 people in my family. I'm not cooking for a commune. I'm cooking for me and my kids. So I would have to divide the recipes down to work for 4 people. Got it? That's a real life use for dividing fractions. Other than that, there aren't a lot of reasons to do it. Again, except that as you go further in life, there are more and more times you need to deal with numbers. Got it? All right. Go to your outline. You are going to be working on dividing, page 134. And you are going to do the following numbers. Now please notice, what did I put in your outline after dividing? Quiz 2. Okay? You've already written a quiz today. I don't want to go too hardcore on you. We'll have that quiz, same thing, tomorrow. Okay? The test will be later tomorrow, depending on how we do. We've got a couple more notes to do, but I don't think we're going to have time today. But we'll see. We're going to get at least... We'll probably finish this unit today. Start tomorrow with the review and a quiz. Okay? We'll mark that review. We'll mark that quiz. Then we'll have our test sometime tomorrow. All right? So I want you doing on page 134. I want you doing 3. 5, 9, 12, 21. And I'm giving you 25 minutes with which to work. That will take us to break. You will come back from your break.
That's our last break, right?
Yep.
And then after the
You will come back from your break. We will do some notes. We'll probably finish the whole unit today.
Will we still do like technical part 2 with that?
Yeah. Because the last 2 aren't that difficult. We'll get them out of the way.